presentation and in other comments that UFS developers are seeking the community input. And we've also heard the recommendations that we want new things to happen in UFS. And often, I think 99% of time, these new things come from the early career scientists. So we want to reward the scientists who attended this meeting and presented their results. I have to say that it was a very hard decision to make because we had so many good poster presentations, not only from the early career, but overall. So you all helped us to select the best presentations. And we had an awards committee who made the final decisions. So the third place goes to Jingshuang Kui for diagnostics of oceanic Kelvin wave responses to westerly wind events in the equatorial Pacific in CMIP 6 models. So let's. Since we have very little time for this, I will just make the presentations, and then at the end of the meeting, I do have the printed copies of the certificates. So the second place goes to John Hammond for developing an early warning forecast of hydrological drought onset, duration, and intensity across the conterminous United States using machine learning models. So we do have work in the pipeline to use machine learning models for the advancement. So let's give a round of applause. And the first place goes to Peng Pei Shi for the 4D and bar-based weekly couple land data assimilation system for E3SM. So this was a hot topic in our discussion. So we do have new work in the pipeline that could help advancing the development of UFS. So let's give a round of applause. That's all I have. Thank you.
Thank you so much for that. Next presentation will come from, well, supposed to be Mark Olsen, but I believe Christine Bassett's going to be presenting this. Talking about our FY25 funding opportunities.
All right, can you hear me okay?
There you are. I thought you were in the room.
No, I will be presenting virtually, unfortunately, but would you like to share my slides or would you like me to share my screen? I can go either way.
I can click through or you can, whatever you prefer.
All right, I will go ahead and share my screen then.
Excellent.
All right, and can everybody see my screen?
We have you.
All right, wonderful. Well, good afternoon, everybody. I want to first take a moment to thank the organizers for putting together such a wonderful workshop and for giving me the opportunity to provide some information on WPO's FY25 funding opportunities. So today I just want to give you a brief status update on WPO's FY25 funding opportunities. And this year we have 6 funding competitions, and at least 2 of these competitions provide opportunities for projects that advance S2S research and applications, which I will highlight in a moment on the next slide. These competitions will be published on grants.gov, hopefully early next week, in 6 separate funding opportunities. And we'll be sure to update our website and communications as soon as they've gone live, so please stay tuned for more information on their official publication. Now, one major change this year that I do want to highlight is that instead of a single omnibus NOFO containing all of our competitions, as we've done in the past, there will be 6 separate NOFOs. And what that means is that if you are planning to pursue funding for S2S related work, you will need to locate each related NOFO separately on grants.gov. I also want to highlight a few key dates in this year's NOFO. We will accept letters of intent until September 25th, and we're hoping to provide responses to those by October 11th. Now, the full application will need to be submitted no later than November 22nd by 5 p.m. Eastern Time, and we're hoping to make award announcements sometime in June 2025. So again, please make sure to check WPO's website regularly for any updates to this schedule. Now, as I mentioned, 2 of these opportunities are especially relevant to the S2S community, and so I would strongly encourage everybody to check them out. The first one is hosted by the S2S program itself, and it will solicit lower readiness level projects, so readiness levels 2 through 4, that focus on topics like improving data assimilation, the development or evaluation of UFS or SFS components or sub-elements, or ensemble strategies and techniques. Now, the climate test bed competition will solicit higher readiness level projects, so readiness levels 5 through 8, as part of the broader test beds competition. And this competition will look for work focusing on improving data assimilation, SFS development, or improving methods for S2S Outlook. Now, please note, I've listed the program manager for each of these competitions, and they will be your primary contact for questions regarding each of the respective competitions listed here. So just to summarize, there are 6 funding opportunities for the research community to consider, 2 of which are directly related to S2S research and applications. I have listed all 6 of the competitions here, as well as their program managers for each of them, as well as their email addresses in case you'd like to inquire about any of the other competitions. I also want to highlight one more internal funding opportunity for our NOAA colleagues. The Joint Technology Transfer Initiative will soon be announcing an internal competition that will be inclusive of all time scales and include opportunities for UFS development, testing, and evaluation. So if you're interested in that, please reach out to Chandra, whose email is listed, with any questions regarding that internal opportunity. And finally, I want to share with you that there will be a webinar introducing our FY25 NOFO next Wednesday, September 11th at 1 p.m. Eastern. If you are interested in attending, please scan the QR code on the bottom right-hand corner of the screen here, or feel free to follow the tiny URL that is listed in the blue text box to register for this webinar. If for some reason you are unable to make it, the webinar will be recorded and posted to our webpage. So with that, I want to thank you for your attention, and we hope to see your wonderful ideas submitted to our funding competition in FY25. Thank you.
Okay, next, we are going to have 2 speakers for the closing remarks. This is going to kick off the workshop. We invited David DeWitt, the director of CPC, to give the first closing remarks, then followed by the director of PSL, Robin Webb.
Yeah, so before I go ahead and get started, I do think that it would be appropriate if we thank Jan and Mark. I think it was a great workshop and a lot of work, and I know you got a lot of help. But thanks for spearheading this. So I've enjoyed the meeting. I hope you have as well. I thought it was a really great workshop. It's the first time we've ever done this inside NOAA. That was really great to see a lot of people I haven't seen in a long time due to COVID. You know, for me, from my perspective, it was great to see diagnostics on predictability, root cause of climate phenomena, at least as best as we can do in our field, given the various limitations. And then, of course, there was a whole session on systematic errors. I thought it was great that we had some concentration on the foundational capabilities, including the reanalysis for the atmosphere and the land, and then, of course, the ocean as well. Extreme event prediction, drought, flood, temperature extremes, hot, cold, both in the atmosphere as well as in the ocean, and coastal flooding. What I'm going to spend a little bit of time here is some areas where I think we could double down on or perhaps invest some more time, effort, and energy, given available resources, or hopefully in the future if we had additional resources. And the first one is regime transition. Dave Novak showed slides of something that's called the Precipitation Prediction Grand Challenge Project that, among others, Robin and I are on the executive committee. Dave is obviously on the committee for that, and that's been something we've been working on for several years to try to get funded with help from stakeholders, but there are many priorities inside NOAA, and to date has not been funded. Hopefully will be funded one day soon. I'm actually going to show an example of the breakdown of predictability and actually studying those limits. This is a really great study that was done by Andy Hole of Physical Sciences Lab. I still reference that when people ask me, you know, if we're going to look at predictability, what would you recommend doing? I say, do that if you can. Novel evaluation metrics. You saw a few here at this meeting. I think we need to expand beyond anomaly correlation, root mean square error, and even things like the Heidke skill score, things that are more relevant to specific applications. And then novel forecast approaches. So I know there were some talks about forecast-informed reservoir operation, which I think from a high level takes the view that, you know, for water resources here in the Western United States, you really can't get a monthly or seasonal forecast that's skillful enough for the understandably risk-averse water resource manager. So instead, you could update at a fairly rapid basis, that being a few days. Forecasts right now that are about a week long, but maybe we could push that out to 2 weeks. I think that's a very promising paradigm. It's been embraced by the Army Corps. And I think people are applying that in different contexts. I think it's an area that we can and should expand on. And the bottom one is missing. I'm sure that it was extremely important, but I don't remember what it was. So then this is the example from the Precipitation Prediction Grand Challenge, which was 2017. We had just gone through the 2015-16 El Nino, which was extremely strong, and despite that, you had basically below normal precipitation over a large part of the southwestern U.S., especially California, which of course is non-canonical. It's two-category myths, however you want to describe it. Then you moved into the winter of 2016-2017, which was La Nina, which should have reinforced the drought, and instead you had biblical flooding. So why do you get these transitions, especially in forcing that you would assume is non-conducive to actually facilitating that regime transition? Why does that happen? And I think if you actually talk to folks, for instance, Western States Water Council or Cal Water, they would tell you getting that one piece of information would be worth billions of dollars. I'm not saying it's easy. I'm not saying that I have any idea how to do it at this point, except for improving models. But you know, the practical reality is getting these huge changes in the circulation. Why do those occur? And in those two particular years, and actually more recently during another La Nina, we had the same thing, La Nina conditions, and again biblical flooding in the southwestern U.S., especially California. Why? Why did that happen? Can we figure that out? Maybe that's something AI/ML could help us with. So this is a study by Andy Hole where you had this flash drought in North Dakota, South Dakota, and Montana. Economic damages to crops and livestock were about $10 billion. So as you came into the May period, you know, it was fairly normal or neutral, climatologically speaking, soil moisture conditions. And then you rapidly went into this situation where it was a flash drought, and then it grew into a more sustained drought. But if you looked at how well models forecast that, every model in the world, everyone was in the same ballpark. You could forecast it maybe at a 3-day lead, maybe at a week lead, and that's just not sufficient for stakeholders to be able to make any decisions with. And so, you know, this sort of a study looking at where we're not doing well, I think is the kind of place where you can make improvements, right? If you happen to be into physical fitness and you work out, and let's suppose you could bench 200 pounds, you don't then go and try to bench 170 pounds because that's not going to push you, right? So I think pushing ourselves to look at cases where we didn't do well and where we could hopefully improve the models, I think is an area where we could improve. So this is a diagram that Dave had also shown as part of our PPGC package. And the important point here, it's a complicated figure, I can make it really simple. So the green blob is current skill, what we can do now. And then the orange blob is what users actually need, what they could use in terms of being able to make a decision, right? Because we all realize that whether or not a user can use our products or services to make a decision depends upon whether a particular skill profile meets their risk tolerance. And then the intersection here in this orange, yellowish green is where, you're kind of at the boundary there. And so, I think it's an important point, and now I remember what was on the last bullet there, which is this topic has come up in this meeting in a couple of different contexts. So, and Ming Ji used to say this. Ming was a man of few words, but some of the things he said were very, very prophetic, I think. And one of those was research push versus operational pull. The fact that researchers are going to work on things that operations may not realize they need, and or is maybe not a top priority for operations, but is critical for the longer term. Jim Kinter talked about this in a slightly different way, which is what do we need to do right now? Okay, the current capability versus the longer term capability. And one of the things I think we have suffered from as a community has been a focus on the short term. We're operations, CPC, but we're also research, if you didn't know that, right? And development and transition. And I think we inside NOAA went through a period, again, people make decisions for various reasons. And there's an old adage, you get what you measure, you get what you fund. And the thing that we have measured and or funded for at least the last decade has been transition. What are you transitioning? So I'll tell you a quick joke. So you go on TV now, they talk about, Alexander Graham Bell, first thing he heard from Watson was, can you hear me? The second thing he heard was, your new car warranty has expired. And if you're in NOAA or you get funding from NOAA, the third thing you heard was, where is your transition plan? I think we need to move away from the focus on transition plans. Not that we don't have them, not that they're not important, but I think we need to recognize that if we're actually going to make progress on extremely tough problems, which these are, we need to actually let researchers do research. I'll use a word that not everyone likes. We need to let people fail. If you go into software engineering in the modern era, agile methods, places like Apple or Google, they spend a lot of time failing, but they fail quickly, but they explore things. I think we in NOAA need to re-baseline around the concept of we're going to let researchers do research. They're going to try lots of things. Some of these things are not going to work. That's good. That's a healthy research enterprise. If we knew the answer, famous scientist at GFDL, Kiko Miyokota used to say, if you can get the anomaly correlation 1 continually today, you don't have a job. We don't have that problem. Okay, so I'd like to see us as a NOAA community, us as a larger S2S community move towards a recognition that, and again, part of this is leadership driven. We have new leadership. Right? We need to focus on higher risk, to a certain extent, higher risk, higher reward research, and let people explore things. And I think ultimately you will then get better forecast skill. And if all we did was just continually making forecasts with the same systems that we have now. And this may be the last slide. And thanks for the time. It was good to see people, and hope to see you at the meeting next year.
Thank you, Dave. This is good for the community. So Robin is going to give another perspective. Hopefully, everybody hears the vision, so we all work together on this.
Yeah, so Dr. DeWitt is a tough crowd to follow, but I really found. So one of the things that I think Dave was pushing, and I think it was Cisco Warner that pointed out to me, it's beyond just sort of what do we need. It's, we talk about use inspired. Cisco brought to my attention the idea of vision inspired. And so vision inspired is actually allowing us to do the foundational activities that will give us then the use inspired. And so I think we should be thinking that way. It's, it's not just, it's allowing the flexibility to say, I'm not sure exactly how this is going to be used, but I know if we do it, it's going to be used. And I think Suki Manabe, Kurt Bryant, and people like that at GFDL, for example, had a lot of vision-inspired sort of perspective. So let me see if I can go to the next slide. So first thing for me, my initial impression, you know, I just want to give everybody who presented, posters, talks, I was just overwhelmed in terms of the presentation of the spectrum of modeling, of prediction and understanding of S2S, really modeling and applications. And I think it was sort of enlightening to me that there's a light at the end of the tunnel. And I think we know there's even a tunnel. And basically that we're going to be able to accelerate and advance NOAA's S2S operational prediction capabilities and the development of the next generation guess and seasonal forecast system. The question I think we have to be thinking about is how and when do we provide operational centers and decision makers with access to this wealth of innovative research advances. It was brought up, I'm going to repeat it, and I use this is a Ming G word, so Ming is big in this. He calls it experimental guidance. OER never does anything but that, and he told me if we ever did, he'd slap my hand, if not the back of my head. But yeah, how do we provide experimental guidance that can be used at their discretion? We provide experimental guidance from laboratories and OER to the Weather Prediction Center, to the Climate Prediction Center. They use it as they see usable. And I think that we want to be able to accelerate that kind of use. And we also want to allow it to be done by decision makers. And that's a tough call, but you know, the bottom line is they're trying to manage risks. And how they manage risks is if they have zero information, that's not useful. So we don't always get to say this is good enough for decision making because the decisions are made based on their perspective. So the other one is that probabilistic approaches to S2S modeling, forecasting, and outlooks, it's never going to be perfect, but it can be used really as actionable science if there is a good ability to characterize robustly what are the strengths and limitations, which in turn highlights a need for the critical role of, we call it social, behavioral, and economic research. We got to engage that as part of what we're trying to do because it's, you know, we can work on the physics, we can work on the data assimilation, but the use of it has to deal with, you know, how people are going to be using it. Next one, I think we have to see our research challenges as opportunities. This is one of my favorite Dilberts. And since Dr. DeWitt likes camping, he'll appreciate this. From now on, we will refer to all our problems as opportunities, says the pointy-haired, chief. And then the executive administrative assistant comes in. One of your idiot spawns was playing with the oven and burned down the house. And then Wally says camping opportunity, but it's research opportunities that we're thinking about. We have challenges, but they're research opportunities. I just wanted somebody to smile rather than frown during my whole talk. So the other thing we have is we have a tension. We have a tension between model resolution versus number of ensemble members. The complexity of the models. Do we include aerosols, waves, and other increased complexity? Little cartoon on the bottom shows the tension. You know, we have HPC that everybody's sort of leaning on. You know, that's our constraint. But what do we do in terms of model resolution? What do we do in terms of number of years? This is a big deal for not just reforecast and reanalysis, but the training data sets for any other sort of applications. And then it's a complexity issue. I did show this under another context, and then during a deposition, a lawyer pulled it out and said, "What do you mean? What's going on here?" But this is a tug of war. Anyway, so you know, if we think about it, there's really those kinds of things. We have to worry about the inhomogeneities when we go and do a reanalysis. You know, if we're going back to 1960, what happens pre-satellite era? You know, the ocean. I mean, there's OBS. There's a lot of issues out there, but there are challenges out there we've got to be thinking about. And then we heard a little bit today, not a little bit, a lot of it, really about the unique requirements for the range of applications beyond more typical meteorology. And we have to think about what is the fidelity of the information that we can provide. And We don't judge it, but we have to at least be able to characterize it. And I'm not going to go through those things except to mention that recreation and tourism is important. It's especially important if you're going to be retiring soon. So systematic errors, typically we identify them as glaring model performance issues that can be compensated for through bias correction and post-processing. My question to this community is really, if we do the bias correction and the post-processing, we're dealing with it in one way, but is that the only way we should be dealing with it? Should we say mission accomplished and sort of go home, or should we really be thinking about the underlying problems and the representation of critical processes? Because I'm wondering how they propagate through the Earth system. And, one of them that we've been focusing on recently is the westward extension of a bias of ENSO in models. How does that impact the model representation of other processes? If we're not getting the cloud coverage right, the shading right, is that going to impact our monsoon representation? Is it going to, impact MJO propagation, evaporation over the Great Lakes, development of a stable marine boundary layer that's critical for things such as atmospheric river prediction? The other one is really we have to be thinking about the initialization and shock. It was fascinating, some of the talks on how we get around that and how we do it, whether we just use long climate runs, but we should be thinking about, is it a mismatch between our reanalysis, our replay, our reforecast, and the forecast model that we're running? Or is it an issue between the observational reality and the model reality, the model world, where the model just wants to go somewhere else? And that's something we should be thinking about. There are other things that I would think, we got to worry about in terms of underlying problems. One of them would be the systematic trends. The fact that no matter what you do, the models like to be warmer. We heard things about convection. I didn't fill these out because they were this morning, and I just sort of was overwhelmed with the amount of information that was being dumped. But winds, the role of winds, the role of that in terms of net radiation over the oceans and things like that. So there's other ones, we have to be thinking about internally consistent reanalysis, replay, and forecast systems, coupled data assimilation, initialization, and shock. There's a unique importance of land, ocean, and sea ice at S2S timescales. And I think we heard that again and again. There's sort of how do we design innovative diagnostics to help guide model development? There are continued advances, but there's also what are those advances relative to the guests and the SFS? We have to be able to pull that in. And there's a number of things listed there. There's the role of AI, machine learning, statistical modeling, and post-processing. We heard that throughout, and then we heard it in the commentary from our esteemed colleagues during their commentary of the development plan for the seasonal forecast. And then we really should be focusing on the strengths, limitations to accelerate the use of S2S innovations in an experimental guidance mode. And I want to emphasize that that's something that we can be thinking about. So to wrap up, I think we need to prioritize our research efforts. And I think we were alluding to that in terms of how we put together an implementation plan. What are the scientific advances that are possible? That's going to be hopefully somewhat bigger than what is feasible, and then the rest of it's going to be what is tractable, what can we do? How do we modernize the S2S operational predictive capabilities? And, let's face it, the CFS was upgraded to version 2, what was it, in March 2011 as a state-of-the-art system. It was pretty darn good. It is now a vintage but robust and stable thing. Unfortunately, when it comes to a forecast system, vintage isn't like a wine. It's not even like a car. The question I would have to all of us, and this is the one that poor CPC deals with, is how many of us are using our 2011 computers today? They're using our 2011 forecast system, and we got to feel good about it. And then I want to sort of think about it as well. Maybe it's not that bad, because if you think about it, Curiosity was launched the same year as the climate forecast system. Fascinating. It's still going. It was only planned for 2 years. I think this gets to Jim Kinter's question of when is your plan replacement? What's your turnover? But, we are doing something very similar to what NASA's doing with its systems. And if you think about it, Voyager's been out there since August 20th of 1977, and it's still going. Do we want to compete with them with our forecast systems? And with that, I'm going to leave you saying I really enjoyed this meeting, and I found the science stimulating. So thank you. Thank the organizing committee and our two real sort of ringmasters. Oh, I'm late.
Wow, Robin, you are really energized the whole audience, this room. Yeah, this is great. So I'm encouraged too. We didn't expect there's such tremendous interest in the workshop. So yeah, we want to continue to work with everyone. That's about the time. Thank you, everyone. Thank you for your attending. Thank you for your support. Have a safe trip.